Bob Martin with rcsub.com and the Nautilus Dry Docks, and this is my latest project I wanted to share with you. This is a 1/96 scale Thor design Seawolf submarine. It is set up for full static diving thanks to this watertight module, and it also features a pair of working torpedo tubes in the front. So over the course of the next few minutes I'm going to get into a lot of technical details. If you're interested in that kind of thing, should be a lot of information for you, and if not, you can skip ahead to my next video, which will hopefully show the operation of this boat in the water.
Alright, let's start with the watertight cylinder. This is really the brains and brawn of a remote controlled submarine. Now this is a Dave Merriman cylinder, 3.5 inches in diameter, set up with a rather large ballast system, certainly much larger than what was needed for this model. But let's start at the front, and we're going to work our way back. So up at the front of this unit you can see I got the main on-off power switch. It's been waterproofed with a watertight boot. This is a lithium polymer 11.1 volt battery pack. Basically, to charge up the unit you simply remove the end cap and plug it in. It's a fairly simple system. Moving forward, you can see the ballast system itself. Now, again, what I said was that this ballast tank was too large by about half for this model. The modern nuclear boats have a very low freeboard, which means that their ballast systems do not need to be extremely large. So what I did, so that this could still be utilized and also add some additional functionality, is I put a rubber bellow inside, and this is from a blood pressure sleeve. So I inserted it through the ballast intakes on the bottom of the model, and basically inflated it through this tube. So when I was trimming the model, I put it in, and I was actually able to blow into this tube until I got the correct reserve buoyancy for the model. So basically this is a section that's reserved. It will always be full of air, and what it also did is it stopped water from sloshing from one side to the other. So there's still room in the front for some water volume, and that sneaks past it through here on the other side. So worked out pretty well. I'm actually kind of happy with how it worked. This is the main pressure vessel for the propel, which is what the ballast system is based off of. So when you blow your tank, the servo in there pulls the actuator against that valve, and it blows liquid air into here, which expands and forces water out of the ballast tank. And this is the propel that I was talking about. It comes in cans. This is the adapter, and to charge it up, basically you just put the adapter over the top here, press down, and it fills that up with liquid air. Moving to the back, now this is where all the fun and expensive parts live. In the back you can see the main drive motor. It goes through a gearbox, and that goes to the output shaft right here. This is a valve that Dave puts in there, and reason being is when you force these end caps on, because of the seals, you're actually pressurizing the entire watertight cylinder. So after you get the end caps put on, you can vent the pressure inside by simply releasing the valve. And the other advantageous thing about this is if you're looking for leaks on your regular maintenance cycles, what you can do is attach a bicycle pump, a manual bicycle pump to this, give it just a couple of pumps, pressurize the cylinder, put it in the water, and you can look for bubbles. So again, that's a really good feature that's built into the model. This is the pump. Now this is Dave's snort system. So basically what you do is you use the gas to bring the model from negative buoyancy up to slightly positive buoyancy, and that's the majority of the water that you're going to be using. But to get it to surface trim, to save gas, you use this snort pump, and basically you turn it on through the transmitter. It's an on-off switch on channel 5, and what this does is it draws air through the mast of the submarine, and it goes in through the pump, and then it goes back through this other channel into the ballast system. So it draws air from the outside, pumps it into the ballast system, and again forces water out. And that's really good for fine trim, getting your water line just perfect. It is a little bit slow. It's really good for smaller models. This type of pump isn't extremely fast, but it does generate a decent amount of pressure. So looking on the other side here, you can see the servos. We got 4 servos here. The main speed controller. LiPo-Guard, which is basically a fail-safe device, and it monitors battery voltage so that it won't allow you to dive if your battery drops below a certain voltage. Here's our main receiver and the ballast system servo. It's kind of hard to see in that spaghetti right there. And right on the side here is the automatic pitch controller. So that's the main drive system of the model. Like I said, it's the important and also the expensive part of the model. This is not a cheap hobby to get into, but for those of you out there who are willing to take the plunge, so to speak, you're going to be looking at somewhere in the vicinity of $500 and $600 for the basic unit. You're going to be looking for a few extra $100 miscellaneous electronics, about $8 for a can of gas, which will actually last you quite a while. And then if you're looking for a hull kit, depending on what you're looking for, you could pay anywhere from $300 to $1,500, depending on your subject, the size, the quality, etc. So let's take a look at the model itself. This was painted with flat black lacquer, red oxide primer, and then a weathered gray nose cap. Weathering was accomplished with pastels, and basically I used a brush to add a white pastel to it. I wiped it in streaks downwards with a soft cloth, and that's how I achieved the weathering on the model. Masts are cosmetic, but the sail itself is actually fully removable for transport. There's 2 screws on the bottom and the entire mast comes off. The forward dive planes are integrated with the lower hull, and what I'll do is I'll crack this open for you now. To do that, you simply grab it by the nose and lift upward with a little bit of force. Now, the catch that I elected to go with is actually magnetic. Magnet on the top, magnet on the bottom. These are rare earth magnets. They've got a lot of pull to them. You can see the flotation foam in the top of the unit there, and that is what was used to bring it to the proper trim. Taking a look at the inside of the model, you can see the ballast that I have. This is a lead nugget, lead strip, and those fit nicely underneath my bulkhead drains. Those are pinned in there. The only thing I have left to do is to secure these in with a little bit of silicone so they don't move around. You can see the torpedo tubes. We've got some on the port and starboard side, and these again are a Caswell system invented by Dave Merriman. Basically, the way this works is you can see a breech here that slides forward and back. This is in the prepped position. You charge up your torpedo. The model pushes this forward, the plunger, which is basically a trigger. Breech slides back and launches the weapon. Again, a very slick system. When you buy it, it basically comes ready to go. So any of you interested in trying out torpedoes, I highly recommend them. Building your own system can be frustrating, and believe me, I've tried it over the years, and this is a great turnkey solution. Now these are a little bit over scale. These are 72nd scale torpedo launchers and a 96 scale boat. So they're a little bit oversized. I don't know that I would personally want to go any smaller for a torpedo launcher myself.
By the force of your words, and my eyes are open, but I can't find the key to lock them shut, so you can never see. Take me for a ride, forget the color light. At least a dozen times my heart has stopped beating from all of your breathing. So take me for a ride before your conscious dies. Forget the love tonight, just cut it all loose before you have to choose, before you have to choose, before you have to.
So getting into the back, we can see all of the various linkages. This is the torpedo launching linkage. And then you get into your rear dive plane linkages, the forward dive plane linkages, and the rudder linkages. As the main drive shaft goes into the back to your propulsor, and this unit has extremely high thrust. Actually, I wouldn't say that you would ever go more than half throttle on this unit. Anything more than that actually trips out the internal circuit breaker on the speed controller, so you just use about half throttle in forward and reverse. Looking in the bottom, you can see all the drain holes have been cut. Drainage and venting are two very important things for model submarines. You want to make sure that water has an easy way to get in and air has an easy way to get out. And taking a look at the upper hull, that's evident. You can see a series of vents that have been drilled in to the model, and that allows trapped air to escape out the top. There's some large holes in the sail, and here you can actually see the two screws that secure it in place. So let's take a look at how we install the cylinder. And again, this is a very simple and straightforward project. Easiest thing to do is to grab the output shaft there. Make sure that my antenna doesn't get pinched. I'm going to lay that rubber tube in the bottom. So we're going to start at the back. You insert the brass pins into the holes. Make sure that your shaft lines up. Slip it backwards. And then all of these magnetic click-on adapters simply match up to their respective outputs on the cylinder. Going to the front, you simply lower it down in place. Now it's in its operational position there. Now this is the retaining pin. Simply put it in place in the front. Give it a little wiggle to secure it. And now everything is locked down. There's no way that it can move. This is the receiver antenna. Exits out the side, and you simply tuck that in alongside the cylinder so it doesn't get trapped on the lip. Now what we're going to do, and this is really the only tricky part of the assembly, simply take your vent mast and insert it into the mast hole that goes up in the periscope assemblies, and it just goes into the mast nice and easily like that. You can see it coming out the top, and that's all ready to go. Rear lip just gets pushed down, that goes back, and you drop it in place. So that's the cylinder installed. And to basically to operate the model, all you have to do is turn your transmitter on, turn the model on, and you are set to go. All right, I just wanted to turn the model on and see how, show you how all of the linkages and everything worked. So the procedure for that is fairly straightforward. Transmitter always goes on first. Turn on the model. You can see all of the linkages jumped there for a second. Let's go to the back. Start with our forward dive planes. And go to our rudder. We've got our ballast. There's our propulsor. Let's see if I can get it in a little closer so you can see. There we go. And the last thing is the automatic pitch control. So your depth control is managed through the use of the front dive planes. That's what pulls the model down underneath the water. The purpose of the rear dive planes is to keep it level. Without it, what actually ends up tending to happen is the model porpoises up and down as you try and maintain control over it. So what you can see here, if I tilt the model, those planes move to try and counteract the pitch of the model. Very slick system. Works really well to keep it on a nice even keel, and that makes for a nice smooth operation. Last thing here is the torpedo actuators. Move one way, it launches one tube. Move the other way, launches the other tube. You can see this fairly heavy-duty magnetic linkage there, and the reason that I went with these really large rare earth magnets is to get a much more positive bite on it, so that when it pulls, it has enough force to pop the plunger on the front. The standard click-on connectors, unfortunately, just don't have enough oomph to make that happen. The last thing is the air pump. Not much to see, but maybe you'll hear it. And it's coming out the top here. That's generating some suction through the top of the unit. So that is the operation of the Seawolf. I want to thank everybody for watching. By all means, check out my other videos under my channel. Make sure that you subscribe for future projects. Thanks for watching, and we will catch you next time.
The force of your blows, and my dreams are shattered by the force of your words, and my eyes are open, but I can't find the key to lock them shut, so you can never see.